Okay, so thank you for coming today on this snowy day. We are going to talk today about igneous rocks and the minerals that compose igneous rocks. So you've seen this before when we talked about minerals and rocks, but we're going to now just really focus in on igneous rocks. We're going to talk about Bowen's reaction series, which is a really neat series. And then we are also going to look at some textural terms. What does it look like when igneous materials cool under different pressures and different temperatures and different conditions? And I have a little video that I'll show you that shows about minerals crystallizing out of a melt that I think reflects, it's a little elementary, but it reflects Bowen's reaction series quite nicely. It's going to be kind of a short class today, I mean not 10 minutes, but ending early for two reasons. One, this is pretty technical, this stuff, so I don't want to overwhelm you for 50 minutes. And number two, it seems like there are a lot of people that can't make my office hours. So if I end maybe 10 minutes early, those of you who keep saying that you can't make office hours, we can talk right after class because you don't have anywhere else to be for those 10 minutes. So we're going to look now at the materials that come out of igneous processes. And the first thing to be aware of is the fact that lava and magma are called such based on where they're located. Magma cools and is inside of Earth. So these are underground magma chambers. And maybe you know this, right? Magma's inside, lava's outside. But the thing about it is that the cooling history is reflected and recorded in the rock once it's cool. And the rocks that cool underground in these magma chambers, meaning they never get shot through a volcano, will have a very different look to them, not a different mineralogy, but a different look, than the same exact chemical composition, that same magma, some of it you can see got shot through a volcano. Compositionally, they are identical. They have the same minerals in them. It's just that texturally, and we introduced this concept before, they look different. So the more slowly something cools, the larger the mineral grains. So magma and lava, we can now introduce the concept of intrusive versus extrusive. Extrusive rock, think external, cooled outside of Earth. Intrusive rock, like internal, cooled inside. So here's a picture of the rocks that will be formed from the magma or lava in the previous picture. What you can see here is that rhyolite is an extrusive rock. It got cooled very quickly. It shot through a volcano, and it went from a liquid to solid pretty instantaneously. For that reason, there are mineral crystals here, right? Because the definition of a rock is that it's composed of minerals. But the mineral crystals are so small that you can't see them with their naked eye. And we'll name that something else in a little while, but for now, rhyolite is an extrusive rock. It got shot through a volcano. Granite is the exact same chemical composition, except it cooled in those underground magma chambers. It cooled very slowly, and so the individual atoms that are migrating around in that magma chamber had a lot of time to group together, and they group together in like minerals. So the crystal size will grow larger and larger. So the larger the crystal size, the more slowly that magma cooled. Some of it cools very, very deeply underneath Earth, and so it has a very, very slow cooling rate. So remember, maybe, that when we talked about these rocks, we said that while color is a poor diagnostic indicator of minerals, the minerals that are in igneous rocks can all be can be classified based on their color. So color is a good diagnostic indicator of igneous rocks. And so we know if it's pinkish white, then it was something that formed on land. Then we have this intermediate, which I'm going to skip past for a minute if you're following along in the slides. We'll go to the other extreme. Greenish black rocks form in the ocean. They are very important rocks from an Earth surface point of view because 71% of the surface of Earth is ocean floor, right? So this is the kind of stuff that cools on the ocean floor if we're looking at basalt. Now, if you just had regular basalt, it would look like this greenish black rock, nothing else. This is a specialized case. There are holes in it, and we'll describe these holes later. So I want to show you a neat piece of basalt. So those holes are from the gases that were trapped in the rock as it was cooling. And then those green crystals are crystals of olivine. We'll look at what that means as well, but it would just be a dark greenish black rock. This top one, Gabbro, again, chemically, mineralogically identical, but texturally, the size and shape of the grains different. The problem with Gabbro, when you're looking at it like this, is it's difficult to see where one grain ends and another grain starts, because you remember when I was talking about igneous minerals, when we talked about minerals, we said that all of these minerals are very dark. Amphibole, hornblende, pyroxene, they're all dark. So you really have to polish a face of it with a rock polisher and then hold it up in the light and look at different angles, and then you can see where the mineral grains end. But for now, you're just going to have to trust me that that is similar to granite, but all of the individual minerals are dark black, greenish black in color. So we know that these formed in an ocean process. Those spreading ridges, right now we're putting things together, spreading ridges, undersea volcanoes, this is the stuff that would be formed. If the magma kind of rose up almost to the surface but not quite and cooled underneath, then it would be gabbro. If it got shot through the spreading ridges, it would be basalt. So then remember, tectonically, I'm going to go up one now. When you have a convergent boundary, and ocean crust is hitting continental crust, I beg your pardon, continental crust, then the ocean crust will dive down, and it can only dive down so deeply before it melts. And when it melts, it sends fingers of magma up through the continental crust. So that's liquid ocean floor that comes up, and it will start to melt the stuff that it's moving through, and it will change the composition of the melted material. So now you have a mix of continental pinkish white stuff and the dark black gabbro-y stuff, and this is the intermediary. Diorite if it cooled slowly underground, and andesite if it got shot through a volcano. So when we're talking about igneous rocks, certainly there are lots of textural terms, and I'll introduce you to some of them now. But the point is, when you're looking at the mineralogy, when you're looking at the chemistry of the rock, color is a good diagnostic indicator. When you're looking at the texture, that's a good indicator of where it cooled. And really, we're talking about 6 rocks, but 3 chemical signatures, right? One extreme, another extreme, and an intermediary. So it's kind of easy to be dealing with igneous rocks. So here's another picture about how these fast cooling rocks are found at the surface. You see the volcano right there. And in the volcano, you see pumice, which we'll look at, and fine grain. This is rhyolite, stuff that's underneath. You can see the grains. This one's neat, and I'll talk about it in a minute. This is called porphyry or porphyritic rock. You see that it's coming from the shallow subsurface, but they're big crystals. What happens here is that the minerals start to cool slowly underground, and so crystals will start to form. And as we'll see, crystals form at different temperatures. And then before it was fully solid, it got shot through a volcano. So you have 2 different cooling histories here. Started to cool slowly, crystals started to form, that half solid amalgamation got shot up through a volcano, and the rest of it cooled quickly. So that's called porphyry. So that's why it's coming from the bottom and the top. So when we classify igneous rocks, now we're putting them on a bit of a table here. When we classify igneous rocks, we classify them based on the chemical composition, or as you see here again, color, and then on the cooling history. So now you have those 6 rocks that we just looked at in, again, more of a table form. You have the land rocks here, granite and rhyolite. You have the ocean rocks, gabbro, basalt, and then you have the intermediary rocks, diorite and andesite. And then we'll look at some other sort of anomalous volcanic processes. But those are the 6 rocks that we're looking at. And we're classifying them, again, based on the texture and the composition. Texture is something that we'll get into a little more detail about now, but the composition is simply the chemistry. So textural terms. Turns out it's not as simple, you might gather, as just saying you can see the grains or you can't. We get into a little more detail about this, and we can look at what the texture is in more detail, going from the largest to the smallest. Pegmatitic, that means really huge grains. You can see some pegmatitic rocks that are having crystals or individual mineral crystals about the size of a car. Huge, huge crystals. So that's the largest size. Also, there's a lot of micas usually in pegmatitic rocks, but huge crystals. This is indicative of a very, very slow cooling history. It's also indicative of the fact that there's a lot of water. There are fluids migrating around, and you may remember when we talked about metamorphic rocks, a lot of water, hot fluids circulating around can facilitate the grouping of like minerals into larger and larger sizes. So there's a lot of water here, but there's also huge crystal grains, very, very coarse grained. The next two are really kind of the ones that we looked at in the previous slide. Phaneritic, P-H-A-N means crystal. So phaneritic, you can see the crystals. Usually, about the size of your pinky nail, about, give or take, is the size of a crystal in a phaneritic rock. So that's granite, that's diorite, that's gabbro. You can see the crystals, they're interlocking in the matrix. A means without. Again, this word crystals, without crystals. It's not that this rock doesn't have crystals, it's that you can't see them with your naked eye. And here we're looking at rhyolite, we're looking at andesite, we're looking at basalt. Minerals that have cooled so quickly that you cannot see them with your naked eye. And these have really a dull, stony appearance. There's nothing beautiful about them, many people would say. A couple of other terms. Put both of these out. Glassy, exactly what it sounds like. You saw obsidian in the previous picture. That is stuff that is rare when we're talking about volcanic processes overall. It's pretty much all glass, all silica. It comes out at a very high temperature and it cools very quickly, and so you have a glassy texture. Again, maybe you're familiar with obsidian, and I'll show you a picture of it. And then porphyritic texture or porphyry. This is something that is two different cooling histories. Kind of already explained this. So the minerals cool very slowly beneath the surface of Earth. Crystals will start to form, and different minerals form at different temperatures. So you have some crystals forming, but they're essentially floating or moving around in the rest of the matrix, which is liquid. And then the whole thing gets shot through a volcano. And so in porphyritic textures, you have two subterms. One is a phenocryst, P-H-E-N-O-C-R-Y-S-T, phenocryst. Those are the crystals. And they're embedded in what we call ground mass. So the phenocrysts are kind of the phaneritic part, and the ground mass is the aphanitic part. Two different cooling histories. So I'll show you some pictures of that as well. And the last two that we look at is fragmental. Fragmental, it is said in geology that there's no such thing as sharp edges. There's no sharp edges when we do topographic mapping. There's no sharp edges when we're looking at rocks. The exception here is when you have fragmental rocks. Remember we said that stratovolcano eruptions, the magma is very, very viscous. It's almost cool. So the eruptions are not these rivers of lava that flow nicely down the side of the volcano. You have this bursting away and explosions. And the explosions make jagged-edged, rocky pieces rather than a lava flow. So you have a fragmental rock. It could be composed of any of these different chemistries, but it will be aphanitic, again, because it is getting shot through a volcano, and it will be very jagged edge, blocky, angular rocks. I'll read you later an eyewitness account of a volcanologist who was running down the side, I think it was Galeras volcano, and there was an eruption, and he describes these things that were all jagged edge, size of TVs, size of cars, falling all around him, and they were smoking, and it was harrowing experience. He managed to survive, though his colleagues did not. So fragmental, angular, blocky. Oh, sorry. And then the last one is vesicular. We're going to talk about, next class, what makes volcanoes dangerous and what makes them not dangerous. Most of the magma bodies have a lot of gases in them. And when the material's way, way down underneath the surface of Earth, and you have the crushing weight of gravity pulling everything on top of it, gases, as you know, are expandable and compressible. So when it's under a lot of pressure, the gases are forced into tiny, tiny microscopic pockets. But as the material rises up, it's under progressively less pressure, which means the gas can expand. And I'll give you an example later of a scuba diver, why you can't come up from the bottom of the ocean really quickly, what that does to your body. So the gases expand, and sometimes they can escape. Other times they get locked in the rock as it cools, and so you have these bubbles. So vesicular, that basalt that I showed you, there were holes in it. Remember, that's called vesicular basalt. In an extreme, we know about pumice, right? What is the characteristic of pumice that makes it so much fun for kids to play with? Yeah, it floats, right? It floats, and it floats because it is less dense than water. The reason it's less dense than water is because it's like shaving cream coming out of a volcano, essentially a volcanic process. And so there's air. There's more air than rock to the point where the whole, and none of the bubbles are interconnected, it will float on top of water. So that's vesicular in an extreme. So it just means filled with holes or wholly. So here's a couple of pictures. There's a glassy texture. This is obsidian, right? This glassy rock. And then we have aphanitic. You can see some shadows here because it's an irregular surface, but you can't see individual mineral crystals. And then you see phaneritic, right? So you can see the crystals. This is more white minerals than it is the silvery and greenish black minerals. And there is porphyritic texture, phenocrysts and ground mass. So again, igneous rocks, the whole point of today is they're classified on two different things, texture and composition. Those are the textures, those are textural terms. The composition is the chemistry, and that is the minerals. And again, we're not talking about a huge number of minerals that make up igneous rocks. So they're pretty simple to look at and to understand. I'll just put these all out so I can talk about them. So igneous rocks are all very rich in silica. They have a lot of silica in them. So by a lot, I mean, so obsidian almost 100%, and a low number of silica in an igneous rock is about 50%. Basalt is considered a low silica rock, and it's about half silica. So the iron and magnesium, you may remember those two elements before. Those are the composition, right, of the core, and then iron and magnesium mixing with silica is the composition of the mantle. So the more iron and nickel you have in an igneous rock, the higher the temperature. T is temperature. The higher the temperature at which it forms and from which it comes. So the mantle, remember, silica mixed with iron and magnesium, has those very dark greenish black rock minerals, rather. So things like pyroxene, olivine, hornblende, and peridotite, the greenish colors. So they all have very dark colors. And then instead, so we call those mafic or very rich in iron and magnesium. The stuff that's in the volcanoes that come out from land, there's too many other things to characterize them as just saying they have these two atoms in them, or these three, silica, iron, magnesium. So we say kind of everything else. Or we say ones that don't have iron and magnesium in them are the lighter colored rocks, and those are the ones that are non-iron and magnesium rich. They form at lower temperatures. So you should be able to be putting these things in their proper context, thinking about tectonic processes, thinking about what happens at the surface of Earth. So the high temperature stuff, spreading ridges, seafloor, non-iron rich, non-magnesium rich, they form at lower temperatures. They're lighter in color, they're lighter in density, they have more silica, and they have more everything else, aluminum, calcium, sulfur, everything else. So when we look at minerals in magma, you should be sort of figuring out this picture that the minerals that form are both temperature and chemistry dependent. So what that means is that the chemical composition of the magma changes as mineral crystals start to form. And when that happens, so does the type of mineral that forms from the magma. This is described by a series called Bowen's reaction series. And again, I have a little video. It's a little bit elementary, but it's good in that it provides you with a visual representation of Bowen's reaction series. The bottom line with Bowen's reaction series, again, when we're taking a mineralogy class and we talk about this in great detail, you have to know a lot about it. For the purposes of natural disasters, know that Bowen's reaction series describes the temperature at which minerals crystallize out of a melt. So as the magma cools, different minerals form at different temperatures. That's it. It has tremendous ramifications in the mineralogic and in the volcanology, igneous petrology fields. But for us, this is a picture of Bowen's reaction series. You don't need to memorize all of these minerals. Just please do have an appreciation for the fact that over here we have the temperature, 1400 degrees Celsius, down to about 800, 700, 600. That's when things are pretty much all the way cool. And what happens is you have this body of magma with atoms just moving around, or some molecules, right? Because some silica has bonded to other atoms, moving around. And as the temperature cools, they group together and they change phase from a liquid to a solid. And it doesn't go all at the same rate. So up here we have the high temperature minerals, crystals forming in the magma, olivine, and then plagioclase feldspar using, we talked about this before, right? First all calcium, and then as the temperature cools and as the melt gets significantly depleted of calcium, it can start to use sodium, uses some, it uses more, and then you get down to the bottom and you have sodium-rich plagioclase feldspar. This side is discontinuous, so this side means olivine is made when the temperature cools and the materials that you need to make olivine are depleted. Then you make pyroxene, then you make amphibole, then you make biotite. The last three things that are on this chart are orthoclase feldspar, that pinkish mineral that makes for granite, right? That's a low temperature rock. And then muscovite mica, and the very last thing is quartz. But all of these things, every single one of these minerals has some silica in it, but you have pure silica forming last of all. So this is the reaction series. And I think I talked about this the first day of class, but it's kind of neat because we talked about New Hampshire being the granite state, right? Granite has pretty much all of these minerals in it. But when we talk about the weathering products of granite, right, you take New Hampshire and you weather it away and you transport it and you deposit it on the Hampton Beach in New Hampshire, all you're left with is silica, right? When you go to the beach, you have perfectly round, because weathering attacks edges, grains of quartz with a little bit of muscovite mica in there that makes the beach look shimmery sometimes. So when you take the temperatures at which these things cool, you're also, if you take it in reverse, looking at the degree to which they are able to be weathered. And high temperature minerals get weathered away instantly, virtually, at Earth's surface temperatures and pressures. So when you have a granite mountain, the stuff up at the top is going to be weathered away. So that makes for these two characterizations, two end members. The mafic rocks, mafic comes from MgFe, mafic rocks. Mafic rocks are the gabbro and basalt, right? And then you can add a textural term if you want. And these are the minerals that are in mafic rocks. They're dark. Over here we have the felsic rocks. Felsic rocks are, again, non-mafic, everything else except iron and magnesium, lots of silica. And these are the three, really, I mean, it looks like it's a lot on that list, but it's three minerals that you know are in a felsic rock. Plagioclase feldspar, which is the whitish colored stuff. Orthoclase feldspar, which is the pinkish stuff. And then quartz is clear, but it reflects as shiny and gray because it's reflecting the minerals that are around it. So those are the two end members when we're talking about igneous rocks. And inherent in this is the fact that they will have different eruptive styles. They will have different hazard levels when we build near them from a natural disasters point of view. And we'll be talking about these from the context of how worried should we be. And this is the slide that puts everything together. Again, you don't have to memorize this, but this is everything all put together. There are the 6 rocks that we're talking about. Komatiite, peridotite, they're called ultramafic. They're that really dark greenish black. You wouldn't really have a cause to know about these or see them unless you're in a very specialized field of volcanoes. So we just look at these 3 columns here. So what you have now is both a textural term and a compositional term. And so on the bottom part here, if you have a rock, you don't know what it is, but you know that it's igneous, first thing you say is, can I see the crystals or not? If you can see the crystals, it's on the top line. If you can't, it is on the bottom line. Now we look at the chemical composition. Again, color is all we need here. We don't have to be a versatile mineralogist. K feldspar is pink. Is it pink, clear, white, and some black? Then it is one of these. Here, the K feldspar is pretty much gone. There's no pink. So is it a mix of white and black with some clear? Then it's in the middle. Is it mostly black? There is some plagioclase here, but it mixes in with sort of color. It makes it look very black. Blackish green, then it's that. So it's simple to classify these. I know I've thrown a lot of textural terms at you, and I've thrown mineral terms at you, but they're not that many of them. And when you're getting to the bottom of igneous material, it's pretty easy relative to sedimentary rocks, say, to classify them. So with regards to thinking about how you would be quizzed on this, for example, you should know the minerals that I just talked about. There's only 6 of them. You should know the rocks, and you should know the environment of formation, essentially. Is it above ground? Is it below ground? Was it in the ocean or was it on land? So that's the main purpose of today. And I want to show you this. I can get the sound working. Again, a little bit of an elementary.
Igneous rocks. So the Bowen's reaction series and magmatic differentiation pertain to these types of rock. In this lesson, we will talk about Bowen's reaction series and magmatic differentiation, which are basically 2 attempts to explain or predict how igneous rocks form. We recall that rocks made from the cooling and solidifying of magma are called igneous rocks. So the Bowen's reaction series and magmatic differentiation pertain to these types of rocks. So who was Bowen, and why do people who know a lot about igneous rocks know his name? Well, Norman Bowen is well known in geological circles because of some experimenting he did back in the 1920s and 30s. Through his experiments, he discovered that minerals crystallize differently as they cool. The result of his research gave us what we call the Bowen's reaction series, which we can define as the crystallization sequence from magma as cooling occurs. As Bowen dug into his understanding of the crystallizing process, he realized that there are 2 sequences that minerals can follow. These are the discontinuous series and continuous series, as we see here on this diagram of the Bowen's reaction series. The discontinuous series is seen on the left, and it contains minerals high in iron and magnesium. We also see that the series progresses with a drop in temperature. When we follow this branch, we see that at very high temperatures, olivine is the first mineral to form. In other words, olivine minerals, which are high in iron and magnesium, tend to crystallize at very high temperatures. Then, as the magma begins to cool, some of the olivine becomes pyroxene. As we progress in the sequence with more cooling, the pyroxene turns into amphibole, and finally the amphibole turns into biotite. You might want to use an acronym to remember the steps of this sequence, such as olive, pits, are bitter. Each step of the discontinuous series represents a very distinct change with the creation of a new mineral. So the change is not a smooth, continuous flow, but instead a discontinuous process, hence the name. With the formation of biotite, the discontinuous series officially ends. But there can be more to it if the magma has not completely cooled and depending on the chemical characteristics of the magma. For instance, the hot liquid magma can continue to cool and form potassium feldspar, muscovite, or quartz. You might want to use a technique to remember these final minerals as well. For example, you could use the acronym PM quiet. The PM is useful because these minerals are formed late in the sequence, just like the PM hours are late in the day. And quiet is useful as a memory jogger because these minerals are formed during the coolest or quietest temperatures of the sequence. The continuous reaction series is going on at the same time as the discontinuous series, and we see it here as the right branch. With the continuous branch, we see the reaction has more of a flow or continual reaction taking place, hence the name for this series. With the continuous series, we see plagioclase minerals. It starts with the highest temperature mineral, which is calcium-rich plagioclase. As the magma cools down, the calcium is replaced with sodium.
Sorry, must be because I watched it already once. They don't want us to watch it again. So that's all. That's really all I wanted you to see, that there is this discontinuous reaction and a continuous reaction, and that is how minerals crystallize out of a melt. So we are a couple minutes early, so I'll end here. Hope you can internalize all that. Anyone who needs to see me, I'm not going to have office hours today because of the snowstorm, so please come see me right now, and we will pick this up on Wednesday.
Yeah, I looked at it briefly. I didn't totally understand it, to be honest. I was looking at the standing deviations of them.
Oh, no. So let me show you. I got some questions about the quiz, so anyone who wants to stay, and I'll explain that Excel spreadsheet that I sent around. We are welcome to stay. Don't need to. So, go to here. There they are, okay. So here, this is the question number, first column. Second one is what the right answer was. And then the difficulty level, I have 3 levels of questions, easy, medium, and hard, so that's a difficulty level. So the yellow is the number, the percent of students in the class that chose that correctly. So you see for question 1, the answer was C, 82%. Oh no, that's not, that was right. Yeah, so 82% chose the right answer. I messed that one up. And so 85, 92, 95. If you look at question 5, you see that there was spread, 45, 16, 17, 22. That to me says that question was not fair. The whole class thought it wasn't fair, so everyone got 2 points for it. Okay. So these yellow numbers are the percent of the class that got that question right. That's what I use to evaluate the fairness of the question. So you see some of them 99, 89, 83, 82%. That tells me that you all as a class thought that question was fair. The ones that are in orange, you see 28, 37, 26. That means that you were equally spread along those 3, so that tells me that that question wasn't fair. So that's the benefit of doing a multiple choice versus a short answer. This is you all speaking very loudly and clearly about what questions you as a class thought were fair and what questions that weren't. So, yeah, so you add 12 points to the first column, and the running total in Canvas, that is your final quiz grade for quiz 1. Okay. And the average, I think, was, when it was a 70 before, it went up to an 82, which is a little high, but, I mean, you can't argue with this. You guys didn't like those questions as a class, so I'm not going to penalize you because I'm supposed to fit you to a 70% normal distribution as a grade distribution.
All right, thank you.
Good, yeah. You don't add anything. Just look at. I have 2 columns. One is your grade. One is the scale. So if you look at the running total, that's your grade now. So don't add anything. Just you add those 2 together. Okay. Good. Yeah. Okay. Sure.
So for the case studies, do we have to know all the numbers that it mentions?
No, I'm not really a number memorizing person. Just sort of, yeah. So, where was it? You know, that sort of thing. What sorts of things happened?
And you also mentioned a lot of volcanoes during the lecture, so we're responsible for knowing those as well.
So if you see like Super Volcano, the film that you're watching, right? That's Yellowstone. It's mentioned in the book. We're spending 2 class periods on it, and I talked about it in class. That's pretty, fair game. I mentioned in passing Arenal. I didn't say much about it except for it's in Costa Rica and it's been going off a lot. So that, you certainly less important than the ones that, like Mount St. Helens, you saw it, it's in the book, it's in lecture, so those would be more important. Yeah, and I can answer those questions. It's going to be interesting. I've not written a multiple choice quiz on the book yet. I've only done short answer, so I can answer those kinds of questions easier later after I've sort of written the quiz and thought about it. I haven't thought about it yet, so.
Yeah, I just, like, I didn't do as well on the quiz as I hoped I would.
Okay.
And like 12 points wanted us, but.
Okay. So, one thing that I tell people to do, and I'm amazed at how well this works, is do what do you call it? Index cards. Writing cards. I never did it in college, but I noticed that when students start doing it in these classes, especially where you have all these textural terms, compositional terms, the process of writing it again, and then it's a more active style of learning. You see it, aphonetic. What does that mean? Okay, aphonetic A without crystals. It's a rock that cooled quickly through a volcano, and then you flip it over, and it's a more active style of learning, and then you can shuffle them so it's not presented in order, rather than idly sort of looking through your notes again and again and again. So that is, again, something that I never did, but I'm amazed when people say, oh, I didn't do well, I got a C on the quiz, and I say, try that, see how it works. Pretty universally, people are like, oh my God, it helps so much. So, yeah, I'd try that. The lectures are recorded, so if you feel like you didn't get something the first time, it's on Canvas. It's Panatopo recordings. You can rewatch the lectures.
What tab is it under?
It's down there, the recordings.
okay.
Yeah, so that's always an option too. I don't love to tell people that they're there because I'm afraid people will stop coming to class, and I think there's value in being in class, but if you want to watch it again, or if you're ill, or if you're somewhere, it's a good thing to, look over. If you missed something, you know that it's there.
Yeah, I'm just like not always sure what the important thing is, because you mentioned some things in passing, I felt like, but then they turn up on the quiz, and I sometimes like miss the notes because I'm trying to understand at the same time.
Yeah,
So
so,
that would be really
well, I think that might help. And then also, right, with regards to that, knowing what's important, that's the benefit of the multiple choice exam. I can see what you all thought was fair. So questions, if you thought, oh, that one wasn't great, look at that question. It may be that the whole class didn't think it was great. And I absolutely will admit when I've, written a bad question, because you can't argue with the data. So I look very carefully at the data in a way that with a short answer question, I wouldn't be able to do that. I wouldn't be able to evaluate, was that fair or not, in a quantitative sense. So, with regards to questions that you feel like, I don't love that. First of all, I do have 3 levels of questions. I have easy, medium, and hard. So some of them are going to be harder. It separates out the A students from the B students. But second of all, it may be that I thought it was very clear. It's a great question. And I think that. And Eric looks at the questions, and we go back and forth twice. Yet still mistakes get made. So I'm interested in seeing my mistakes and seeing how I can not penalize you for my mistakes. So, okay?
And is glassy really fast cooling?
Yeah, very fast cooling in all silica.
And what was the spelling for the sphenocryst?
C-R-Y-S-T. The first part is right. C-R-Y-S-T.
And that would, and porphoric materials.
Yep, that's right.
Slow cooling.
Yep, you're good.
And it's fragmental, so
Fast cooling.
and vesicular is fast.
Holy, yeah, and fast cooling. Yeah.
And then, like, the gases get stuck in the minerals, and that's why there's holes in it.
There's holes in it, yeah, because the gases got bigger. Yeah, exactly.
Thank you.
Exactly. You're welcome. Hi.
I'm John.
Right, we
Nice to meet you.
wrote on email.
Yeah, I don't think so.
Oh, no, okay.
Maybe a different
Sorry.
time.
Maybe, yeah.
I'm talking to something kind of unrelated to class. I'm filming this video as part of this group called Agape Latte about this kid named Dorian. Have you heard of D Strong online at all?
No.
There's a kid who's tragically dying of terminal cancer. He's from Rhode Island. He's 8 years old. And his dying wishes to be famous. So he wants to be famous in China because he loves the Great Wall. And he thinks he'll help him pick up girls if he's famous. So people have posted pictures like from the Great Wall, like you're famous in China. And so we're making this video at BC. And I think it'd be really cool to get a shot of this entire room, like really quickly before or after class. Because it's like, how many seats in here? 300?
Yeah, 220, I think. Yeah. Sure.
Even if they just yelled like "Stay strong, Dorian" for like one of the last scenes.
Yeah.
It's like a minute video.
If you can do it at 9:58 and 9:59, I have, being in environmental science, people always want to come in and talk and proselytize the students. So I have a no guest spot policy in my classes, but how can you argue with someone who can't? So if you could keep it to, people come in early, right? So if you can
Yeah,
keep it to,
typically.
like come in at, you know what you can do? I think if you type on the discussion board, everyone can see it. Or I can write an announcement and
Yeah,
say,
if people-
can you come in a couple minutes early if possible? There's someone who wants to do this. So yeah, you want to
Yeah,
do it
and
on
I
Wednesday?
could just set it up, right here, and
Yeah.
then just do it really quickly.
Yeah,
Yeah,
let's
that would
do
be
that,
really,
yes.
really appreciated.
Yeah, no, that's really sad and good for you for doing that.
Oh, no problem. Maybe depending on how much time we have, if I could play Geronimo and the speakers, and people could dance for like 20 seconds, and then you just got a shot at it. But if it's pushing it too much, I'll just stick with
Ask
stage
them.
show.
Come in 5 minutes
Yeah.
early and ask them.
Okay.
Until 10, it's all you.
All right.
All right?
Deal. Okay.
Yeah. And
Thank you.
yeah, sorry, I just have to ride the
No,
line.
totally. Should I email you so
Plausible
you can
instruction.
forward it to people?
Yeah,
or
if you
should
want
I-
to do that, yeah, sure.
Okay.
Sure.
Sounds
Yeah.
good.
All
All right,
right,
thank you so
excellent.
much.
All right, yeah.
By the way, I'm Sophia, but I go by Sonia at Leon.
Okay, yep.
Office hour now.
No, we're good. Yeah, okay, good. So you were gonna come before, Friday morning, okay. So
Now I'm good.
I'll be there, so if you have any other questions between now and Friday. Yeah, and try the note cards.
Yeah.
Thank you.
Yeah.
I am Sarah. I'm a graduate. We were emailing a little bit. I did not do as well on the test as I thought I would, and I took your class, the first section of it in the fall of last year. And I studied for the test about the same way. That might be different because of that semester it was short answer
Yeah.
stuff, and this is multiple choice. How is the extra credit gonna factor in?
I don't know
semester?
about it yet, so,
Yeah.
yeah, I
Okay.
don't know about extra credit yet, and when I do know about it, it's something I would tell everyone out of
Right.
fairness,
No, yeah, of
everyone,
course,
so,
of course.
yeah, I haven't thought about it yet, I'm
Okay.
working with the distributions, and I know it's always frustrating, especially with these multiple choice, when I was bad at taking multiple choice,
That's where
hated it,
I can
hated
explain
it.
to you a lot of
Yeah,
things, but it's just
yeah.
not in the specifics. Do you
So-
think there'll be one opportunity in the semester or multiple?
I don't know yet. I
You don't
really,
know?
yeah, I don't
Okay.
know, and I wish I could tell you. I don't know, and also again with this whole notion of fairness, I don't know that I tell one
You
person
can't
from
tell.
inside
Right,
track.
right.
But yeah, I will figure it out.
Okay.
There were a lot of TAs last semester, and this semester there are 0. So I mean, Eric's already seeing 2
Yeah,
classes,
right.
and the nature of crappy adjunct work is that I have to be driving all over Boston teaching classes in different campuses. So I don't have the resources with
Yeah.
which to grade 300
Of course, yeah.
essay quizzes 4 times, and it's important to me that you do 4, so that if you mess up on one, you have more
Right.
choices rather than a midterm and final.
Is the so I know the way that you split it up is you can either take the 4 quizzes for 25% or the 5 for
The
20.
final, yeah.
Right, exactly. Is it an option that you would be willing to offer for everyone as maybe taking 4, including the final, and just doing 20%, or is it only those 4 quizzes?
It's those 2, yeah.
You
it's those
can't-
2
you
options.
can't do-
So,
okay.
Yeah, it's either 4 or 5.
But is it the 4? Does it have to be the quizzes, or can one of those count as?
No, you have to take the 4 quizzes.
Okay.
And they count.
They're the
because
25.
At some point, BC is really tough on making sure you have a normal distribution.
Okay.
And so
So-
my hands are tied, right? The administrators
Yeah.
won't invite you back to teach if you're handing out A's like candy.
Okay.
I wish I could hand out A's like
Yeah,
candy,
yeah,
right?
of course,
I
yeah.
think that would mean that everyone could calm down about their grades and learn and enjoy the class rather than, being worried
Stress
about
over it.
stupid, multiple choice exams with random facts that you have high
Right.
stakes on it. I don't like that, but
Okay.
that's the
Okay,
nature.
and I heard what you said about the index cards, so
Yeah, I
I'll
think
try that.
especially with the multiple choice quiz, that works really, really well. I've
Right.
noticed people bring their grade up 1 or 2 letter grades by, I don't know what
Just
it is, and I
drilling
never
it,
did,
yeah.
just writing them again, the process, how am I gonna construct to this card? Like they remember the cards, they've said that, they
Right.
remember the cards and writing that card.
Okay.
Rather than, flipping through your notes or rewatching the lecture and your
Right.
brain checks out. It's an active style, right?
Okay.
Of making them and then also testing yourself. You read it, you answer it, and then you look to see if you got it right, shuffle them around. So
Alright,
that's
so
usually it.
okay.
Yeah, and anything I can do.
Okay.
I'm always in office hours.
So is the office hour right after the class?
Yeah,
It
it's
is.
Monday and Friday, 11 to 12.
Okay, perfect.
Yeah, and I teach on night class here Wednesday, so I'm here Wednesday afternoon all day.
Okay.
So it's not posted, but I'm here.
Okay, all right.
All right?
Thank you.
You're welcome.
Hi, I'm Julia.
points even?
I mean, like, it wasn't awful, but like, yeah, even with the 12 points, it was like pretty awful. Like, or 78 for the 12 points.
So there will be extra credit at some point. I don't know what it's going to be and when it's going to be. And I also noticed that for people that are trying and are conscientious about this quiz is without exception the lowest one. So I think, you know, your grades, if you're like most students in this class, if you're coming and you're paying attention to it, that that's the lowest grade that you can expect. In terms of, you know, whether to withdraw. And I hate withdraw, so it's seriously, you know, you feel like you absolutely have an A or, you know, your world is going to be over. Yeah, that's not something I can promise, but I can help you all you want. Maybe come to my office hours.
I know, you are here Wednesday, because I can't, I'm not on there, and then I like practice.
Oh, okay. So yeah, I teach at 6:15 over in Gasson. So if you ever want to meet before,
Yeah.
and sometimes I'm in McElroy for dinner with former students, so we can talk about things then too. So,
Yeah.
for dinner. So yeah, I'm here in the afternoons if you ever want to meet.
Okay. Thank you.
And before class works too, but today it didn't work because they closed the parking garage and they closed the parking lot and you don't know where to put your car. So.
Thank you.
All right,